Hello and welcome to another video. Today we have a very special board on our bench. This is an NZXT N7 B550. There's very few of these. I've had an NZXT board on my bench before, and the big problem is that there are absolutely no schematics for these available whatsoever for not a single board. And I'm kind of scared to try this repair, because as soon as there's a knocked off component or something like that, we're just out of luck, because there's nothing we can check for that. So let's start with our usual checkups. So we're going to be starting by the 12 volts, and the 12 volts have high resistance, and the 12 volts to the face seem to have also high resistance. Let's get a good probe. Yep, that seems to be high resistance. Yep, 12 volts not shorted into the face. Let's then connect up a good ground here. Let's see, 3.3 volts, not shorted. Then 5 VSB, not shorted, 12 volts, not shorted, 5 volts, also high resistance. Good. Then, because there's nothing that we can probe basically, because everything is encapsulated, except like I could probe the 3.3 volts right there in the PCIe. That has also high resistance. Let's get power consumption into here, get a CPU into here, and see how this behaves. This being B550, I don't think a 2200 will be recognized. So let's go with the 3100. So let's also, oh, there's a power button on here. Do we have a speaker? No, nothing where I can plug a speaker in. Okay. Well, let's then just see now. 120 milliamps, that looks fine. Let's see, do we have a reaction to the power button? And we do have a reaction to the power button, and we're stuck on a DRAM LED. Okay. Then let's plug RAM into here. And see where this board wants to go then. Power button. CPU DRAM LED. Constantly stuck together. Interesting. Do we have any change in power? We do not. And resetting also does nothing. So it does react to the power button like it should. Let's see for different RAM slots then, if we get in different behavior in different slots. But so far CPU and DRAM LED continuously together. And also testing the last slot right here. But every single one of those has the same reaction. I would want a clear CMOS here. There's a button on the back with which we can do that. So let's try that. There's a clear CMOS button right there. Let's press that down for a little bit with no power connected. And let's see again if there's a difference now. No. Oh, now we have way less power consumption. That is weird. And now I cannot get this board to turn off again. What? Okay, just after pressing the clear CMOS, we have different behavior. Because before we had like 1.5 amps or something, and now we have almost nothing anymore. Let's try a different CPU in here. We will probably have to get all of these heatsinks off of here and see for that area where the clear CMOS button is, because this is weird. Yeah, for a very short second we had higher power consumption and then lower again. Let's turn you off. Let's get RAM out of here and see how it behaves without RAM. Also the same behavior. And with RAM in here, let's see, can we see that? No. Weird, very weird behavior. But everything is definitely plugged in fine. So we will have to take this thing apart. Get like everything off of here. All of the heat sinks and all. And see if there has been anything done to this board already, or what we can see from there. So there's a bajillion screws that I now have to keep track of and take out of here. So let me do that. I don't even know which way to start, but I will just start now to take off screws. So that removed fairly easily. Interesting, this is a built-in Wi-Fi card, or a slot for that, and then goes to there. But I want to take the heatsinks off as well here. Okay, now this took quite some time, but now this is naked. I am not jealous of people who have to do like laptops that take really forever to build up, to take apart, because this is already too much for me. But we have the same behavior. So one weird thing is, in standby, you can see these flicker for a short second. I would expect that these are always on. So let's do the clear CMOS again, and let's get this BIOS battery out of here and do an actual clear CMOS. I don't know how they design it like that you cannot get the BIOS battery out without taking all of the shielding off. Let's see now. Same behavior after clearing the CMOS. So, because we have the option to, let's see if we can do a BIOS flashback on this thing. Because there's a button at the back for BIOS flashbacking. So, let's just try that. So, I will have to go to the manufacturer's website and find the right BIOS for that. And I will be trying to flashing it on there. So, I never had to do this for NZXT. And I went onto their website for instruction manual of the N7 B550, and you download the BIOS, you extract the BIOS file and rename it creative.rom. Then you take a USB flash drive with FAT32, put it into there, 24-pin adapter, turn on the supply AC switch, do not power on the system, plug the USB into labeled BIOS, press the BIOS flash for about 3 seconds to begin the process. The button will flash to indicate the process has been started. Please wait until the LED stops blinking and has turned off, indicating BIOS flashing process has been completed. Okay, so easy, just what you need to know. It needs to be called creative.com. .rom.com, yeah, sure. So let me do that and try. So the BIOS flashback function didn't work. I spent like over an hour now trying to get the BIOS flashback to work, and it didn't. So I just pulled the chip off and flashed it myself. Luckily, NZXT provide the actual BIOS file that you need, and I have taken that chip off and flashed it, and we get the same behavior. But what I've done then is I have plugged in the DDR tester, the DDR voltage tester, and if we now turn this on and zoom down, we can see the third one is already missing, which is VDD. And the VDD is the 1.2 volts, the actual DDR4 mainline voltage. And then I went ahead and had a look right here. Let's go under the microscope and not the camera again, to that phase controller. And there's one very weird looking resistor right there. And this looks to be the power for that resistor, because you can see a very big trace going there. And normally I would expect that to be like a 2.2 ohm resistor or something like that. So let's see, is this side shorted? 16 ohms, that looks very bad. And this side has 18 ohms. So I think we have a short circuit here. And I would want to feel if that controller gets hot as soon as I try to power this up. Because it might be. Oh. Now we have the power consumption again. Does the bot want to boot up now? There's something weird happening here. Now we have these 2.4 amps, 3 amps. The board now wants to work. What is this? I just scraped a little bit and put my finger onto that controller. No way that's something... Nah. What is happening today with these repairs? I've had such weird repairs today, and this seems to be just yet another one. I just put my finger on there, and all of a sudden everything came back to life. No way. No way. Let's get a post screen into here. Let's see for that again. 2.3 amps, DRAM, CPU, and actual boot behavior. The fan turned lower. Let's see. And now we get a boot. Do we get a picture out of here? Let's connect a power button, a keyboard, and see if we have initialization. So there's still something happening. These are still changing, just like the current is still changing. 2.5 amps. I have no LEDs anymore, and it's on. It was on. As you can see, the indication is there, but I cannot do anything anymore. Does this freeze because DRAM voltage isn't there properly? Is this maybe doing an update or something that I'm not seeing correctly? I really cannot tell. It's so... But the board should be frozen because we do not have the indication on the keyboard. So let me press the reset. And let's see again. The LEDs, now the LEDs are coming up. Now I'm stuck on a CPU LED. Okay. Now VGA and now boot. 3.6 amps. 2.8. Still changing in behavior. But again stuck on with the keyboard. Not reacting to anything. Is it maybe flashing the BIOS by itself currently? I would want to get a graphics card into here to see if we might get a video output out of this. Oh, you know what? I'm trying. This is not a APU that I have here. I'm trying to get a video output out of a regular CPU. Let's see if the 4300 is supported that I have here. Because the 2200G is not supported that I have. Let's see if the 4300G gets a boot here. And it seems to be booting just fine. There it is. And we have an NZXT logo. I cannot believe this. It is actually working. I do not know what to say to that. I didn't expect this to go this way. So I will definitely have to resolder that controller because you were able to see on that DDR tester that it wasn't there, and we had that 700 milliamps of power consumption only. And all I did was to touch up that resistor a little bit, just scraping it. So I will want to resolder that resistor definitely to have good connection, because this could happen again. So let's go under the microscope. That control, because first I thought that controller might be dead because of the resistance that we saw there, but yeah, it just booted. So let's get the post screen out of here and get the microscope in here again. There's that resistor that I was talking about that is looking very weird. And all I want to do, I just want to touch both sides up of it. And I want to see if it's still 2.2 ohm after that. Because if a component like is partially cracked or something, just touching the component with a soldering iron can either break that component if it's already like partially broken. So I either want it to be actually holding up well, or just break now. But it seems to be fine. So let's check again with the multimeter, and we want 2.2 ohms, I'm pretty sure, across this. Let's get a good connection. Yeah, this is basically 2.2 ohms. Yep. Interesting. Okay. Well then, that seemed to be all that was necessary for this resistor. Like, I've never seen anything like this. Because something is clearly weird with that resistor, but there's connection now. Because you can see it looks like its top got blown off, but it works fine because the chip, the main chip, looks beautifully soldered on there. So what we're going to do, I'm going to be populating all 4 DIMMs of RAM onto here. And I want to get at least into Windows to see this board and then build it all up again and then see if it also still works. So after having resoldered that resistor, let's populate all of the RAM. So we definitely put stress on that controller. So okay, all of the RAM is in here. Let's also plug the BIOS battery in here and let's turn it on then. Yeah, so seems to be working just fine. It's now should be RAM training. Let's get the post screen into here. We should get a post screen, an updated one every second now. Cannot believe it. There it is. Just working fine. Okay, and it recognized all of the DIMMs. Let's turn this off. Let's get an NVMe into here and let's get into Windows. And when that works, I will be putting back all of the heat sinking and we'll be trying it again. Now we have a quick post because we were RAM training, or we had the RAM training done already. Let's now see, we want to see the preparation of devices for Windows. And now we see devices being prepared for Windows. And we are going into Windows. Cannot believe this. Such a weird repair. Such a weird behavior on this board. Never seen anything like this. Okay, let's turn it off again. Let's see if when I will be putting back all of the heat sinks, all of the screws, if the tension of that can maybe already break our board here and bring us back to a state where it wouldn't work. That would be very interesting to see. So I will speed through this. Let me build this up with all of the heat sinks. So after 10 billion screws, let's try this again and see. And it looks very good. We now have an NVMe in here. I got the capture. I have 4 DIMMs of RAM in here. And let's see now. 1.7 amps. And it's now not posting anymore, is it? Resetting. It's not posting. Can you believe it? I'm flexing the board a little bit just to see if I get any change anywhere. Okay, let's get RAM out of here. Partially. Let's see again. 1 stick of RAM. And now we get post, I think. Yep, now we get post. Okay, let's see with 1 stick of RAM then. Let's see now. The board is resetting by itself. The board is doing a lot of back and forth with resetting. Seems very weird how it's behaving currently. Let's cycle this ourselves. Pressing the power button again. Did I put the other CPU in here? No, I did not, right? Yeah, there's the 4300G still in here. But it's struggling to get an actual post in here. And it's resetting by itself. But I don't see any LEDs coming up. Oh, but the board booted. Because I do have indication on the numlock. So the board is definitely on now. So it's just something with my capture that doesn't work properly here. Yeah, there it is. It was just my HDMI wasn't plugged in properly. So let's turn it off. And let's plug all of the RAM in here again. Because I want to see this work with all RAM sticks. Because we had problems with the RAM voltage. So now it should be doing new memory training. Yeah, and it doesn't like that. Doesn't like to have all the RAM in here currently. So let's take 2 sticks out. Let's have it run again. Okay, also doesn't seem to like that. Let's get a normal RAM configuration, so with 2 and 4. And this seems to be fine now. This seems to be booting with 2 and 4. Yeah, there it is. So in Windows, we're going to turn off again. Now we have 2 sticks of RAM within A2 and B2, I think this are, yeah, A2, B2. So let's turn it off. Let's get another one in. This time we're going to be plugging in B1. Let's see. This looks good. Yep, there's the pause screen. Let's turn this off already, because I don't want to get into Windows yet. I want to plug the last stick of RAM into here. So getting the last stick of RAM into here. Now wanting to see it actually boot up, and that looks very good from the power consumption. And there's the logo. We should be getting into BIOS now. There's the BIOS. Okay, turning it off, putting in the NVMe again in order to get into Windows with 4 DIMMs of RAM in here. So yeah, and there we are in Windows with this board, 4 DIMMs of RAM, and it just working, as you can see, reacting. And yeah, so I will be doing some tests with this board. Probably I will be doing maybe a stress test or something, but I think we are just fine now. So what was wrong with this board? There was, I think, a bad connection on a 2.2 ohm resistor. That is the supply for the UP controller, that is the phase controller for the DDR. So that was a very weird behavior. We had like 1.7 amps at the beginning, or 2.4 amps, and it was stuck on that. And then I did a clear CMOS and only got 700 milliamps then. And from that point, then I flashed the BIOS, no change. And then I went on to that. Then we put in the DDR tester and saw that VDDQ was missing. I went into that area, saw that resistor, scraped it a little bit, and put my finger onto the UP controller with some pressure. And all of a sudden, the board started working. And yeah, after that, I just resoldered the resistor a little bit, and it's definitely 2.2 ohm. We have checked that. And now everything is working. Like, oh, this is really weird. Like, I didn't expect to get anywhere with this board, but yeah, seems like we were able to fix it. Well, if you want to call that a fix, but now it's working and it's up and running. So I hope you learned something. I hope you enjoyed this video. Thank you very much for watching. This was MainBotMatic. All of my tools, as always, are linked in the video description. Thank you very much, and goodbye.